Welcome to episode 15 of the PM Blend. I'm Mark Powell. Joe Finksler, to my right.
Hi, Mark.
Joe.
Good to have you back.
It's great to be back. Where else would we rather be?
I don't know. We're in our new digs yet.
I
haven't thrown us out of this one.
I'm still kind of getting used to this new setup.
Yeah, you know? I'm sure they'll throw us out of this if they know if they have any sense.
You know, our next is in the parking lot.
I know that. That's what I'm expecting. We're going to be in the parking lot.
This is our last stop, and then we're thrown outside. And maybe that would go pretty well.
That would probably go fine.
I don't know. But today we're going to talk a little bit about PM gears. I got to my left, Doug Haynes, and over to Joe's right, Phil Parks. So welcome, gentlemen. Welcome back.
Hi, guys.
Thank you.
Glad to be here.
Yeah, you guys were the star of a show a few episodes ago. But,
I don't know if I call star, but...
yeah, we don't know if we call star either. But welcome back. But before we get started, if you haven't watched our last couple episodes, we did discuss our 50-year anniversary here at Atlas Press Metals. So company started back in 1976, Joe, correct?
Yep.
And here we are, 2026, 50 years later, and still going strong here in Du Bois, Pennsylvania. So we're celebrating our 50th year this year. We've got some new commemoratory logo stuff. And
the boys have got all kinds of fun stuff, I'm sure.
Yeah. And fortunately for us, they've kept the podcast going through these 50 years.
Well, if we're lucky, they'll superimpose the logo right over top of our faces during these episodes, so that
there's lots of different things
might
animation-wise it can be done.
Yeah, that's true.
To spice us up a little bit, or to clean us up.
I don't know if we can be more animated.
I don't know. I don't know. Well, listen, we appreciate you joining us today, and want to kind of get right into this topic. Again, we're going to talk about powdered metal gears today. And I guess the first question I'll just kind of throw out to the group is, what's involved in designing a powdered metal gear versus designing a machine gear? I'll just kind of throw that out there, and whoever wants to jump in.
In general terms, there's not a whole lot to that. I mean, an engineer designing his gear form, whether it's in a gearbox or a geared application that he's trying to drive something, the generalities of that, whatever they're mating up with, don't really change. The parameters don't change. What may change is if you're into a multi-level gear or something like that. We've got a few examples here. There may be some things because of our process, because we're loading that and making the full form in a single stroke. We have some tendencies that you may not see in a hobbed gear or some other type of gear manufacturing process in order to make a more robust gear for our form, and also an alternative to theirs, because if you're going to hob a gear, you may not be able to go down to a flange area and get a full form, so that shape of that gear may be different in those applications. But in general terms, there's no real form difference in a gear.
The only thing I would say, just a minor detail, that may be different is when we're making a PM tool, we got to make sure that we have a certain size tip or root radius, just because of the way we're going to manufacture that tool. Whereas if they were machining, they may have the ability to leave a tip radius sharp. We don't prefer that it's sharp. We want, maybe a 10 thou radius at that tip and root. Maybe minor, but to us it's pretty important.
Yeah, and just since you mentioned the tools, and I don't think I actually had a question based on that later on, as far as tool life when you're working with gears, pretty similar to any other structural part?
Basically similar to any other standard PM part that we make, where characteristics are basically the same. Yeah. It's not that much different. When there's things we can do to help prolong the life of the tools also, with coatings and stuff like that. So.
Okay.
What may impact it on occasion is, obviously, in most gear applications that we're producing, they tend to be higher density. Mm-hmm. So you may see a little bit more wear in those cases, and in some minor instances, the powders may be a little more abrasive than in some applications, but
all in all,
Phil's right. Yeah, all in all, there's really not a whole lot of difference in it. It's the wear factors of that gear are not going to be radically different than any other.
There are things that we can do to battle that, to help keep that down. So
okay, all right. Well, then, Phil, I'll just kind of jump back to you. Which mechanical properties are most critical for PM gears in high load applications?
Well, when you talk about, especially high load applications, depending on the gear itself, is it a chain driven gear? Is it a gear to gear? Obviously, strength of the gear is important. And there's so many different types of materials out there that we can use to get that strength, which that's really not an issue anymore. Depending on applications, obviously, I mean, gears go into a lot of different applications, but metallurgically wise, PM gear can, basically do anything a hobbed or full form or full dense gear can do. I don't see any difference between what we can and can't do with those. Pretty similar.
Yeah. Well, Doug, that kind of leads into the next question. How do PM gears compare to a machine gear when it comes to performance?
Yeah. So, I mean, similar to what Phil said, I mean, they can perform as well as a wrought material, but I mean, when you're looking at a PM gear opposed to something that's machined out of wrought, you're looking at the same characteristics. You're looking at the yield strength. You're considering the tensile strength, the ductility, the fatigue strength, the hardness, all those things. I mean, all the materials we use have those characteristics. So when you're designing a gear, we're considering all the same things as if you were looking at a wrought material. Right, so those are the things that are important. But some of the applications through my career have been pretty heavy duty. A lot of automotive applications, and all those gears are PM gears.
Transmission gears, transfer case gears, a lot of, like I said, a lot of chain driven gears. But like Doug said, when designing tools, there's things we can do with a powder metal gear that it's a lot cheaper to do than it is with a full form gear. We make the parts. Obviously the parts are lighter to begin with, but we actually can put lightening characteristics within the gear itself to make it even lighter. Because most car companies or most companies will they really prefer as light as possible. So there's lots of things we can do in the design process.
And as an aside to what they were also kind of dancing around, when you're machining a gear, you have to deal with the wear of those tool bits and the loss of control of dimensional side and or surface finish. The nice thing about our process is we build a tool, and as we've talked about in other episodes, the tool is very consistent. So the surface finishes are consistent and the dimensions stay consistent for hundreds of thousands of parts.
Yeah.
So that's the added advantage. You step that customer away from having to deal with that dimensional variation when you get into that.
Okay. So I hear, or maybe I don't hear in this case, that gears have some PM gears can be a little more, can reduce noise. How is that?
The porosity in the part itself it serves as a dampener. But Joe had alluded to, the other things that are important with noise is, the surface finish. If you can maintain that surface finish, whereas, when you're machining a gear, if that tool breaks down and the surface finish, degrades a little bit, you're gonna create some noise within the gear-to-gear meshing. So those things alone, and dimensional. You talk about, Joe brought up the dimensional control that we have. Obviously that dimensional control has a lot to do with the way those two gears are going to mesh. If you don't have good dimensional control throughout your process, that's going to play into the noise too.
Yeah. Consistency, yeah.
And bringing up the whole porosity thing, the other advantage we bring to the table, that porosity allows any lubrication to stay near that surface. So that surface is going to be lubricated. So besides having the porosity, you then fill, in effect, that full of the lubrication. That softens that sound and also keeps that lubrication near the work area.
Working surface.
And that keeps things quiet as well. So there's the whole combination of the design is very effective at keeping that noise down, as opposed to a wrought machined gear.
Okay. Well, I know that everybody's cost always comes up, and here we are. Why are PM gears considered more cost effective for certain applications, maybe not all, but for certain applications.
Well, I mean, just like any other powder metal part, I mean, we're gonna compress a gear that's, near net shape. Machining is expensive, no matter what you're machining, but machining is very expensive to do, a very expensive operation. So just putting the teeth in alone saves you tons of time, lots of time, and lots of waste. You save trying to machine those gear teeth out of a piece of steel. Mm-hmm. So just machining costs alone, you're going to save a lot of money. Yeah, and then like Joe had mentioned, also that the repeatability of that over and over and over.
Right,
It's yeah, definitely.
In a handful of places that we do machine our gears, it's usually we're machining the round core because it has to be pressed onto a shaft or a bearing's being pressed into it. We're not machining a structural feature of the tooth form or some other area of it, so you've eliminated all of that. In addition, the material that's in our gear is what you bought, as opposed to a machine gear. You're throwing away all the material you're cutting away.
Yeah.
Chips, yeah.
And on some parts, where you have if a tooth doesn't go all the way through, on some of these you can see the tooth goes all the way through. That's very easy to machine. That would not be very easy to machine, whereas that's very easy for us to form.
Right.
A tooth that, any kind of tooth form that comes into, like this one has this, has that hub spline on it.
Right.
That would be very difficult to machine, whereas, for us to form that, that plays into that too. It makes it much easier.
In order to keep that gear short, you'd have to machine the outer section and broach down or cut down a gear and then turn around and make the other gear and press it into it. So now you're having to do two different machining operations and just makes it much more complex. So that drives the cost down dramatically.
And that cycle time you just described compared to our 7 or 8 seconds, we're forming a part. There's other processes downstream, don't get me wrong, but to form that actual gear shape is much, much quicker in PM.
Right. So how does powder metallurgy help reduce material waste compared to other manufacturing methods? You kind of already touched on that.
Yeah, we kind of just touched on that,
Yeah.
Yeah, a lot less chips to throw away when you're machining powdered metal than you compare to wrought steel.
On a lot of the parts sitting here, there's not a lot of machining on them, especially for the gear forms. There's no machining on them, right? Whereas, if you're machining it, every single tooth, you're throwing out a good chunk of material.
Right.
And if we've done our job correctly from a tooling standpoint, the other advantage we have is in a lot of cases, we don't have to do a post-heat treat. We'll use a material that allows us to sinter harden, and we have a very tight dimensional control on those materials, so you don't have to come back and re-hit or recut areas that you may have to do in a more conventional gear. You don't get that distortion.
And if you have an application where you don't necessarily want the through hardening, powder metal gears can also be induction heat treated, right? So if you just want that surface hardness, we have the ability to do that as well.
Doug, I know you mentioned your experience with gears in automotive. How about some other industries or applications where PM gears are most commonly used?
Well, there's a lot, but I mean, some of the ones, obviously lawn and garden, there's medical applications, there's obviously automotive appliances. Joe, you could probably throw out even more, but there's
gearboxes. It's basically in just about everything that we deal in. It's if a customer's got some gear-driven systems, but lawn and garden appliance and automotive are the big users besides electric motors and gearboxes, and those they're going to have a set of gears in many cases. But you can, it's all over the place. Any place should have a gear.
Yeah.
I know, those are some of the areas where we may have worked with. I mean, like Joe just said, if there's any gear application, you could probably find a PM solution for it.
Right. So, guys, what advancements in materials, processes, or equipment are driving improvements in PM gear performance?
Equipment-wise, the advent of the CNC controlled presses have certainly made a huge difference. Years ago, you would have had a single level part. That's the way you would have started, and you would have then had to stack and or assemble a gear. Now, just sitting in front of you, there's 2-level, there's 3-level gears, and with additional compound areas that you might have drive systems that you mold right in, all together right into the gear, it just has made a huge jump in what we're able to design and build and make it better. You know, the old equipment, some of those designs were there, but when you have a cam-driven drive system, it just doesn't allow you to move the material around as readily. Being able to control that material is probably one of the best things that we've had in the gear side of things.
Yeah, which drives that density up, which makes a better gear altogether.
Okay.
Other things, materials themselves, they become more consistent, allowed us to press to higher densities, which then in turn gives better mechanical properties.
Yeah, you had
from that
mentioned
aspect.
center hardened earlier versus heat outside heat treat or so on.
Center harden's another item that brings into it. So there have been a number of advancements over the years. I mean, 50 years ago, 60 years ago, it wasn't uncommon to see most of the gears being copper infiltrated. And that just introduces a whole myriad of dimensional control issues, costs that go with that because of the copper that you're adding to it, and it just introduces a lot of inconsistencies that you don't want to do in very tight tolerance gears. With the increase in density that we're now seeing with the materials in the equipment and presses that we have, it just has driven up the ability for us to make more unique and higher strength gears.
Okay. Well, guys, AGMA. So I'll kind of throw this out to you two here. How does AGMA or AGMA quality level factor into the design and performance of PM gears? And kind of what determines the achievable AGMA class for any given application?
I mean, is it the lower the number now than it was?
Well,
the higher the number?
it depends which
Kinda
grade
switched
you're
it
in.
around.
It's flipped,
Kinda
right?
switched it around.
It flipped, yeah.
But it still comes down to the tolerancing, right? I mean, that's what most of AGMA is really all about. I mean, it's how well you can hold the form of the tooth, which we do very well. I guess, like we said before, it's all within the tooling, and if you, depending on the materials you're using, like Joe had mentioned, and you guys had talked about already, center hard material, the growth factor really isn't that different, so it doesn't change much during the process. You know, and other materials that we use, like nickel or copper, they tend to either shrink or grow, which they're just got to add for that scale factor itself. But as far as AGMA is concerned, I mean, we can hold a pretty tight AGMA. Obviously, there's form error that's going to be with any tooth, no matter how you make it. Mm-hmm. What that number is, off the top of my head, I don't know what we can actually get to.
Well, it was 6, 7 in the old standard. I mean, if anything below that was not a problem. Now in the new standard, it's the other direction, and I think they cross over very similarly in that. I think it's like a 5, 6 neighborhood now is what we would make, in the ones are the highest.
Yeah, and
dimensional tolerance that we can't get down to that.
Yeah, and there's other things we can do too. There's secondary operations. We can mold in the gear itself, and then also do a secondary operation for sizing to help improve that if we have to. So there's things that can be done afterwards.
Yeah, and I think if you're an engineer out there watching this episode and you're looking to either design have a new project where you're designing gearing, or looking back at some current gears that you are having machined, a great way to look into PM is to give us a call or reach out to us. And these two and Joe and our team of engineers like to be involved in that design process, and we certainly can help out with design recommendations as far as how do we get that gear to be a powdered metal gear versus a machine gear. And,
sure.
Certainly would be able to maybe help find you some cost savings there.
That's the objective, yeah.
Yep. While still giving you the performance of a machine or hobbed gear. So,
yeah, cool.
Yeah. Anything else, guys?
I don't think so.
I don't know.
I'm good.
Yeah,
we covered it.
Yeah. Well, thanks for coming back for another episode. We appreciate you guys.
Always glad to be here, Mark.
Yeah. Thanks, Doug. Joe, always a pleasure.
Mark, I appreciate it. I enjoy having your smiling face.
There you go. Well, thank you again for watching episode 15 of the PM Blend, and please do follow our socials. you.